Hello everyone. Today topic database management system introduction. In this introduction part, we are going to cover purpose of database system, levels of abstraction, database languages, data models, database users and administrators, overall structure and history of database. With the definition of DBMS, we can start the session. What do you mean by DBMS? DBMS is collection of interrelated data and set of programs to access those data. Like if you want to store large amount of data, you can choose DBMS. Also, with large amount of data, you can store set of programs to access those data, which is said to be tool. A tool to access the data, which is also inbuilt with the database management system. You can access the data in DBMS in an easy and convenient way. Also with full authorization when you do insertion, deletion or modification. Like if you want to change something in the data, otherwise if you want to add something new, otherwise if you want to delete something from the database, everything can be performed with full authorization. That is the aspect with the DBMS. Database application areas in banking sectors for storing all the transactions. In airlines, you can store details about reservations and schedules. In university, student details, registrations, their grades can be stored. In sales, you can store about customers, products, and purchase informations. On-train details like order tracking and customized recommendations can be stored. In manufacturing sector, supply chain management and other details can be stored. In human resource, employee details can be stored. So in each and every case, vast amount of data can be stored and retrieved in efficient way. Why we are going for DBMS? Like already we have file processing system in the earlier days to store large amount of data. There are some certain disadvantages with the file processing system. To overcome this, database systems come into existence. What are all the disadvantages? Data redundancy, that is repetition of data. Whenever there is a repetition of data, which leads to inconsistency of data, that is available in file processing system. And difficulty in accessing data. There is no certain programs which is inbuilt with the file processing system to access the information. You have to write code for accessing every time when you want to access the data. Then comes data isolation. If you are storing data in different formats, they will be isolated in different parts of file processing system. They cannot be called together whenever it is necessary, as they are in different file formats. Integrity problems. Integrity is nothing but you have to define certain constraints. If you need to define it when you are inserting or deleting, in that case, file processing system will not allow you to define certain constraints, that is rules. Then atomicity of updates is one of the problem existing with the file processing system. Concurrent access, parallel users with the database data is not allowed with a file processing system, which may cause inconsistency in file processing system. Then security problems. There is no authorization rules defined with the file processing system when you want to access the data. So these are all the disadvantages with the file processing system. To overcome this, DBMS comes into existence. How they could overcome? DBMS has its own set of rules, own set of data structures to store the data, and authorization rules and protocols to maintain all the criteria which are all not satisfied with the file processing system. Like it can overcome the redundancy and which avoids inconsistency by using functional dependency concepts. So multiple file formats, duplication of files are allowed, but it is maintained well with the protocols in DBMS. And then difficulty in accessing, as I told you before, DBMS has its own tool to access the data. There is no need to write it separately whenever you need to access the data. Data isolation. In DBMS, all kind of data can be stored in different formats. Whenever it is necessary, they can be collectively called, retrieved to the user in certain format with the user specified. That is a specification about DBMS. Integrity problems. Integrity constraints can be defined. Like integrity problems, constraints are such as when you want to insert the data, you can define certain constraints under insertion condition. If you want to delete the data, you can define certain constraints under delete conditions. Similarly, integrity constraints can be defined with the DBMS. That is also allowed. Then comes atomicity of updates. What do you mean by atomicity of updates? Like when you are, for example, some amount of amount is transferred from one account to another account. For example, there is an interruption in between. In that case, either the transaction has to be done or undone. That is possible with the DBMS. Like it is a rule Whenever there is an interruption in intermediate of the transaction, it has to be undone. Otherwise, you have to completely done in order to make the consistent data persist in the database. Concurrent access by multiple users. You can access, multiple users can access the same data at the same time. Even they can update at the same time. The serializability protocol available in DBMS can make it consistent and relevant to the data which is stored. Then security problems. Authorization rules are maintained by database admin in order to make the data safe and secure. Levels of abstraction. There are different levels of abstractions. Physical level, logical level, and view level. Physical level is nothing but the data, actual data which is stored in the database is physical level. When you are defining relationship between the data, then it is logical level. And then view level, whenever the user requests certain data from the database, certain data which is necessary for the user alone will be retrieved and given to the user. Remaining data will be hidden from the user. That is what higher level of abstraction, view level. And physical level is the lower level of abstraction. This is a diagram which depicts the different levels of abstraction of the database. Physical level, logical level, and view levels will be different in numbers, depends upon the different number of users. Some terminologies have been listed out here in DBMS, instances and schemas. Schema is nothing but logical structure of the database. Database contains information and the relationship among the data also defined with the database. That is said to be schema. There are two types. One is physical schema and logical schema. When it is defined at physical level, then it is physical schema. When it is defined in the logical level, then it is said to be logical schema. What do you mean by instance? See, if you are doing certain modification with the database, for example, I'm updating the current salary in the employee database. In that particular moment, at that state, the overall database is said to be instance. So that is what the term instance tends to specify. Then data independence. So data independence is important characteristic of the database because whenever the data are independent, you can maintain it easily and also it will overcome such conflicts with the data. In that case, there are two types of data independence, physical data and logical data. When you are doing certain updation in physical level, that will not affect in logical level. That is said to be physical data independence. When you are doing certain updates in logical level, that will not affect in the physical level. Then it is said to be logical data independence. By following these kind of data independence, you can avoid conflicts with the data storage. Then we are going to see about different languages in DBMS. Like data manipulation and DDL, data definition languages are very popularly used languages to access the data to manipulate the data with the database. Data manipulation language is a query language which is used for accessing and manipulating data which is stored in the DBMS. There are two types of DML languages. One is procedural and another one is non-procedural. Procedural languages allow the user to define what data has to be accessed and how it has to be retrieved. In non-procedural, the user can allow to specify what data alone need to be needed, not need to specify that how it has to be retrieved. Non-procedural is also said to be declarative, and SQL is most widely used non-procedural query language for accessing database. DDL, that is data definition language. When you want to create relation in the database, when you want to create tables in the database, then DDL commands are used. Also to create data dictionary, DDL commands are used. There is an example given here. To create a table. Create table is a key query, which is the table name account with certain attributes like account number with their data type, branch name with their data type, and balance with the data type. In such a way, a table can be created with the database. It is a type of DDL command. And what do you mean by data dictionary? Like it stores data about the data, like metadata. When you are creating a database relations, the database has its own characteristics, the schema structure, the language is used, the integrity constraints which is specified, and then referential integrity with respect to the table, authorization rule, everything will be mentioned in the data dictionary. If you want to create a data dictionary, DDL commands are used. Then we have to see some introduction about SQL in this session. Like SQL is structured query language. As I told you, it is widely used non-procedural language. There are certain examples given to explain about SQL queries. If you want to access customer name from the customer table, Then this is a sample query here using select command with where and from class you can retrieve certain information from a table with a constraint specified. And another example has been given here to make you familiar with this SQL queries, where there is here only one condition used. Here there are two conditions specified to access account balance from depositor and account. Two different relations are used, two different tables are used, and with the constraints from two different tables, account balance is going to be retrieved for the user. In as well, SQL can be used with some programming languages. In that case, it is said to be embedded SQL. As well, SQL can be used with some open interfaces, application interfaces like ODBC and GDBC. Some introduction have been given with SQL. We will see SQL in detail in later sections. Then data modules. What do you mean by data modules in database management system? When you are designing a database model, database management system, data model is the primary step. Like you have to design a data model, then you have to go for an implementation purpose. Data model is a collection of tools for describing data, data relation, and the semantic and constraints. There are different types of data models exist. Relational model, entity relation model, object-based data model, semi-structured data model, and other order models or network model and hierarchical model. First, we see some basic information about relational model. Relational model is a tabular format data model in which we will store database in table format, which consists of rows and columns. Columns have the attribute headers and the rows have information about the data. Information about the entities we will see in detail. It is a simple structure which elaborate the table structure of relational database with the attributes and the header, and rows have information about the certain entity. And here it is a database which has more than one table because we store information and make relationship among the information. In that case, many data are stored. Many data have been stored in table format and relationship among them also defined with certain constraints. So always database will be collection of tables in relational database. Then database design. So when you want to do design, ER model is the best choice for designing the database. For implementation, you can go for relational database. In database design, there are two basically physical design and logical design. In physical design, basic layout will be different, and logical level, relationship between the physical data will be defined. See here, entity relationship model have been given with some basic information like in entity relationship model, entity is nothing but a thing or object, any kind of thing in object in a real world. Relationship will be defining the entities to get related to each other. That is what relationship. Every entity has its own set of properties, then that is said to be attributes. Here, an example, a diagram has been given. See, this customer and accounts are said to be entity with their attribute set like customer ID, customer name, customer street, and city. All are in customer entity, which defines the property of customer. And then here account number and balance defines the account entity properties. Then depositor is a relationship between the customer and the account. Like customer deposit amount in the account. This is a relationship. This is a simple example for ER model. And other data models like object-oriented data model and object relational data model also exist with the database modules types. In the next session, we have to see about architecture. So with this, I wind up the session. We have seen about some introduction about database models, their purpose, and some terminologies with the database. In the next session, we will continue with architecture, database system architecture. Thank you.